Welcome to the next video. So let's try and understand now the concept of logarithms. So I'm going to write out a question. So 2 to the power of x is equal to 8, and we're trying to find out what x is. So we can use logarithms to determine this kind of question. So one key note to remember is whenever you're trying to solve an equation where the unknown is a power, we're always going to use logarithms to work that out. So obviously we know the answer to this, if we think about it, would be 3, because 2 to the power of 3 is equal to 8. Okay, so with this question it's relatively easy because the numbers are quite nice. But imagine we didn't have nice numbers here. Imagine we were trying to work out, say, 2 to the power of x is equal to 123, let's say. Obviously now this is going to be much more difficult. So how can we work out any question like this where the power is unknown? Well, that is where logarithms come in. So let's try and understand some notation now in terms of how we can use logarithms. So imagine we were trying to solve this question and we didn't know, for example, that 2 to the 3 was 8. The way we can rewrite this in terms of log notation is to write it like this. So I'm just going to write it out quickly. So what this is saying is 2 is my starting number. This little 2 here, this little number here, we call the base of the logarithm. And another way to think about it is really your starting number. And this larger number here, the 8 in this case, is your finishing number. And really what this log function does is it tells us how to get from the starting number to the finishing number using powers only. So how do we get from the base or the starting number to the finishing number, in this case 8, using powers only? And at the moment that is x, we don't know it. And how could we determine that the answer is 3? Well, luckily your calculator can evaluate this kind of thing. So you would type in log, and then you would say base 2 of 8, and in our case we know that that will be 3, and you can also confirm that using a calculator. So let's look at a few more examples like this. So if we, for example, wanted to work out log of 9 to base 3, again, if you were to put this in on a calculator, you would get the answer. But this kind of thing, because the numbers are nice, we know that the answer is going to be 2. Because how do we get from 3 to 9 using powers only? Well, it's going to be 3 squared will give us 9. So the answer is 2. Some more examples. So something like log of 1 to base 5. That's actually going to be 0, because 5 to the power of 0 is going to be 1. Okay, so how can we maybe write all this in some notation? Well, what we can say is log of b to base a is equal to y. If that is true, then what we can say from that is a to the power of y is equal to b. Okay, because really what we're saying is how do we get from a to b using powers only? Well, we're told the answer is y, so therefore a to the power of y is b. Or another way you could think about it is a to the power of y is equal to b. That's the order. Let's now look at what we call laws of logarithms. So there's 4 rules to remember. The first one we've already had a look at. So if log of b to base a is y, then it's true to say that a to the y is equal to b. And this is really this first one is the fundamental definition of what a logarithm is. Number 2, log of a plus log of b is actually equal to log of ab. And what we're assuming is that all these have the same base. They have the same base of lowercase a. Okay. Log of a minus log of b is equal to log of a divided by b. And log of a to the power of x is equal to x times log of a. So what this fourth one is really saying is if I've got some kind of if I've got a log to a power, what I'm able to do is then bring the power down the front, essentially. That's what that's doing. And now x is down the front, or the power's down the front. And let's look at a question now to apply the laws of logs. So we want to express 2 log 3 to base a plus log 11 to base a as a single log to base a. And so I've put on 3 of the 4 log rules here to the right hand side so we can see how we can apply them. So the first thing to do with a question like this is to think about how many logs you're starting with and how many logs you're trying to get to. So here we're starting with 2 logs and we're trying to get to a single log. Okay, so let's have a look at the relevant rule to apply that. Well, this rule here would be 2 logs to 1 log, and this one here would also be 2 logs to 1 log. Remember, this one here is simply just 1 log to 1 log again. We're rewriting it. So definitely we would either want to use this one or this one for this question to start with, and because there's a plus here, we're going to use this one, this top one, with a plus here. Okay, but one thing we need to notice is that this rule does not have any numbers in front of the logs, whereas in our question there is a number in front of the log, and you have to be very careful with that. So that means we can't straight away use this top rule in this question. We have to deal with this 2. We don't want this 2 being in the front here. So what we can do first is actually use this rule down here, and we're going to start on this side and move to this side, and then having used this rule, then we can use the rule up the top here. So this question actually involves a combination of 2 rules. So let's see how we can do that. So this part here, using the rule down here, can be rewritten as log of 3 squared to base a, because really what this rule down here enables us to do is if there's a number in front of the log, you can then take it to the top, and that's what we're doing here. So this bit here, we're simply taking that 2 up the top, and then the other log is still log of 11 to base a, and then we can simplify this to log of 9 to base a plus log of 11 to base a, and then that means using this first rule we can essentially combine them as 1 log now, and we do that by timesing the 9 and the 11 together, so that will give us log of 99 to base a. Let's look at this question. So here we've got what we call the log equation. We've got log of 4 minus x to base 5 minus 2 log x to base 5 is equal to 1, and we want to find the value of x. So how can we approach this question? Well, one thing to think about is if we want to find the value of x, it would be nice to remove the logs completely from this equation. So how can we do that? Well, if we think about that rule that we came across before, so log of b to base a is equal to y, and if that is true, then that means that a to the y is equal to b. If we could somehow get our log equation into this form, then we can use the rule to then remove the log in this way. And once you've removed the log, it is then much easier to work out the value of x from that. So that's what we're going to do with this question. So we would like to somehow aim for this form here. So 1 log is equal to a number, essentially. This is what this is saying. So at the moment we've got 2 logs is equal to a number, but we want to get to 1 log equaling a number. So we want to think of the relevant log rule to use that will convert 2 logs into 1 log, and then we can remove the log. So that is the method here, 2 logs to 1 log, and then we can remove the log. So the best rule to use here, because there's a minus between the 2 logs, is to use that rule that we came across, log of a minus log of b is equal to log of a over b. So that is essentially converting 2 logs to 1 log. So let's apply that here. Also, one thing to mention is this rule can only be applied again when there are no numbers in front of the two logs. So here again in this question, similar to the previous one, we've got a number in front of one of the logs. And so if you remember, we used that other rule where we were able to take the power in front of the log up. So that would be something like this. So we're going to use both of these rules here in this question. So let's do that then. So this left hand side is going to be log of 4 minus x to base 5. And let's take the 2 to the top. So that will be x squared when we take the 2 to the top there using this rule here. And now what we would like to do is to combine these two as one log. So we're going to use this rule here. So the way you could do that is you can say that this is your a, the 4 minus x, and then the b is all of x squared. So using this rule up here, then these two logs will be combined as 4 minus x over x squared. And that's equal to 1. So to base 5. It's equal to 1 because of this one here. Right, now what we can do is we can use this rule here to remove the log, and now that will then make finding the value of x much easier once the log is removed. So how can we use that then? Well, what we could say here is we could say that 5 to the power of 1 is equal to this bracket here. Okay, that's what it's saying. Going back up to here, a to the power of y is equal to b. And so what we could do using that relation is to say that 5 to the power of 1 is equal to 4 minus x over x squared. Okay, 5 to the power of 1 is just 5, so let's just write it as 5. Okay, so you can see now that we've basically got an algebraic equation here. And so the rest of it's straightforward. It's just algebra to solve this for x. So this times both sides by x squared to remove the denominator. So that's going to be 5x squared is 4 minus x. And because this is a quadratic, we want to get one side to equal 0. So it's always good practice to solve these. So let's take everything to one side and 0 on the other. So that will be plus x minus 4 is 0. And then always check to see if we can factorize this kind of thing to solve it. So that should be 5x minus 4, x plus 1, so that equals 0. And then that means that x is minus 1, and x is going to be 4 over 5. And if we look at the initial restriction in the question, we're told that x has to be between 4 and 0, and so therefore can't have this one, and this is going to be the answer. Let's look at another question. So we want to solve log of x plus 1 minus log of x is equal to log of 7, all to base 2. So again, when we talk about solving, we want x equals. We want to remove logs, and then we can much more easily solve for x. This question is slightly different to the previous one, but it's very helpful to always be thinking about the direction you're aiming for. So what we said in the previous question was if we could aim for something like log of, say, some log is equal to a number, something like this, then we can definitely remove the logs from that. So in other words, in this case it would be a to the y is equal to b. So that would be one scenario. So one log is equal to a number, and then you can remove logs. But there is actually another goal to aim for. Maybe this first situation is not always possible in a given question. So you could also aim for something like this. One log is equal to another log. Now these again have to be to the same base. And if you ever get this kind of situation, it's true to say that a is equal to b. So in a sense you're crossing out these logs. You're what we call inverse logging both sides. And if that isn't clear that we're able to do that, well, imagine you were on this side, you were starting with a is equal to b. If you were to take logs of both sides of this algebraically, you would get this side over here. So it's very important with any question solving log equations, always hold in your mind that you're aiming for either scenario 1 or scenario 2, and once you've got there you can just straight away remove logs in either one of these two options. Okay, so let's have a look at this question. So what we really have here is we have 2 logs is equal to 1 log. So we can either try and change this equation to 1 log is equal to no logs, or we can try and change it to 1 log is equal to 1 log. So in this case, scenario 2 is probably easier to aim for, because on the right hand side we've already got 1 log, and so all we need to do on the left hand side is just to convert them to 2 logs, and we can do that with that familiar equation that we had, log of a minus log of b is equal to log of a over b. So we can definitely use that rule here. So we're going to apply it to the left hand side here. So then that will just become log of x plus 1 divided by 2, sorry, divided by x rather, and that will be to base 2, and then that will be log of 7 to base 2. And so what we have here is really this scenario here, scenario 2. Now 1 log is equal to another log to the same base, and then what that means is, according to this side here, that we can straight away say that x plus 1 over x will be equal to 7. And then all we need to do is just rearrange this algebraically, clear the denominator would be ideal here, and then taking x away from both sides, so we have 1 is equal to 6x, and then that means that x is 1 over 6. Let's have a look at this question. So we want to solve 5 to the x is equal to 3 to the x plus 1. So in this case there are no logs in the question, but we still need to find x, and the best way to do this would be to take logs of both sides. So when do we typically use logs? It's really when we have an unknown power and we want to solve for that power. So here, we've got 2 unknown powers here on either side. Now we have a choice in terms of what base we're going to take logs to. So you could take logs to base 5 because there is a 5 here, or you could take logs to base 3. It doesn't actually matter as long as it's one of them, and even then, to be honest, if you were to take logs to another base apart from 5 or 3, you would still get the same answer, but there's a little bit more work to do. So let's take logs to base 5 of both sides, so let's do that. So log of 5x, and that's to base 5, and then that will be equal to log of 3x plus 1 to base 5. Now what we can do is we can use that rule, that log rule that says that log of, say, a to the x can be written as x log a, and we can then take the x down the front and also the x plus 1 down the front here. So that will become x log 5, and then we're going to take all of x plus 1 down. So I'm going to put a bracket around it just to avoid confusion, and then we have that. Now log of 5 to base 5, that's actually 1, and because it's saying how do we get from 5 to 5 using powers only, that's just going to be 1, so we can rewrite the left hand side as x, and then x plus 1 log 3, 5. Now how can we deal with this right hand side? Well, we're trying to get x on its own, and it may look a little bit confusing here because of this log of 3 to base 5. How can we deal with that? Well, this is actually a number. If you were to use a calculator, you would it would give you a decimal answer. So one thing you could do is to just put this into a calculator and get a decimal answer, and it might be easier to deal with from there. But let's maybe leave it as a log for now, because sometimes in questions they would want the answer to be in terms of logs rather than decimals. So it's good to know how to do both ways. So let's at this point keep this as log of 3 to base 5 and think about how else we can deal with this. Well, if this is a constant here, this is a number, what you can do is just expand this right hand side out. So that will become x times log 3, 5, and we're going to write it like this, okay, plus 1 times log 3, 5, which is just log 3 to base 5. Now one thing I want to mention here, why did I write it like this? So imagine we wanted to write x times log of 3, 5. Now best practice is to keep the log, to keep the x to the left of the log. So write it like this, as we have done, as opposed to writing it like this, log of 3x 5. If you were to write the x to the right hand side, this means something completely different. And the reason for that is this log really protects the 3. So you can't just bring the x in with the 3 because the log protects it. And so best practice with this kind of thing, when you're timesing a number by a log, make sure the number is to the left of the log. That's one thing to be aware of. Okay, so we have this over here. Now, how can we make x the subject? Remember, we're trying to solve for x, we want to make x the subject. Now, the problem in this equation is we've got more than one term containing x. So this is a common technique that you may have come across at GCSE. So when you've got more than one term containing x and you're trying to make x the subject, what we need to do is to group all the x containing terms on one side and then everything else on the other. So for example, if we did x minus x log 3, 5, and that was equal to log of 3, 5, now we've got both terms containing x on one side and then just the log on the other. Then what we can do is factorize by x. So that will become 1 minus log 3, 5, and that's going to equal log of 3 to base 5. And then, remembering that we want to make x the subject, you could just divide through by these two terms because it's x times these two terms. So what we can do is divide both sides of this equation by 1 minus log 3, 5. Minus log 3, 5, and then we can simplify that. These will cancel, and then we just have x is equal to log of 3 to base 5 over 1 minus log of 3 to base 5. So this is x. Now this would be the right answer if they said give your answer in exact form. If you ever saw that in a question exact form, that would be in the context of a log question, we would want log of something in the answer. Okay, just a side note, there are other cases where they would like exact form. That would be, depending on what you have in the question, an answer with a root in it, for example, or something with a log, as we've mentioned, or even a fraction, you know, something like, for example, 1 over 7. 1 over 7 would be the exact form, because if you were to evaluate this on a calculator and get a decimal, you would get 0.1428 with other decimal other numbers after the decimal. And so another way to view exact form would be essentially the opposite of a decimal answer. So the exact form of 1 over 7 would be 1 over 7. The non-exact form would be the decimal answer, 0.1428. So if you ever saw a question with logs in it and they wanted the exact form, you know that you must have logs in the answer. If they don't specify exact form, so they either don't mention it or they say, for example, give your answer to 2 decimal places, for example, then you know that it's not going to be exact form, in which case you're going to evaluate the logs in the answer. So for example, in this question, if you wanted it in non-exact form, you could actually use a calculator to work out log of 3 to base 5 and then just evaluate that. So let's just do that quickly. So log of 3 to base 5 would be approximately 0.68, and then divided by 1 minus 0.68, and then that is going to equal approximately 2.125.